Grade 9 Tangent and Circle. Solution for number 3 from the sheet Tangent. This lesson is prepared by Imad Ahmaidan and registered by Ahmed Hamad. So please stay focused and let's begin. Consider a circle C of center O and a radius 4 cm and diameter AB. Let K be a point of the circle C such that AK is equal to 4 cm designated by P the symmetric of O with respect to A. First of all, we have to reproduce the figure. 2A. Show that the triangle POK is right angled at K. B. Show that PK is tangent to the circle C. C. Calculate PK. 3. The tangent to the circle C at B cuts PK at M. A. Show that the triangle MKB is isosceles at M. B. Show that AK is parallel to OM. C. Deduce that K is the midpoint of PM and OM is equal to 2 times AK. 4. Show that the 4 points KOB and M belong to a same circle whose diameter is to be determined and radius is to be calculated. First of all, we have a circle C of center O and the radius 4 cm and diameter AB. So first of all, we have to use the ruler to draw the diameter of this circle. We open the compass to 4 cm as radius and then we start drawing the circle. And this is the circle C of center O and radius 4 cm and diameter AB. The diameter is equal to 2 times radius, so 2 times 4 will be equal to 8 cm and it's called AB. And of course the whole circle is called C. Let K be a point of the circle C such that AK is equal to 4 cm. We can just put the point A at the top or at the bottom of the radius of the diameter AB. It doesn't matter. What matters is AK must be 4 cm. So K must be on the circle and the distance between A and K will be equal to 4 cm. So using the ruler we can just replace the point K. Designate by P the symmetric of O with respect to A. So A is the mirror. P is the image of O with respect to the mirror A. So the distance between O and A is equal to 4 cm because A is on the circle and the distance is a radius to the center. So we have to draw 4 cm from A to the outside of the circle. The same distance will be P. So AP is equal to AO because P is the symmetric of O with respect to A. To A, show that the triangle POK is right angled at K. This is the triangle POK. We have to say that the triangle POK is a right angle triangle at K. So the angle at K is equal to 90 degrees. In a triangle POK, the median from K is equal to the half of OP, which is the hypotenuse. Then this triangle is a right triangle at K. We have to prove that AK is equal to the half of PO. And as we said previously, AK is equal to 4 cm. This is given. And PO is equal to 8 cm because the distance between PA is equal to 4 cm and the distance between A and O is equal to the radius, which is also 4 cm. So 4 plus 4 is equal to 8 cm. PO is equal to 8 cm. And AK as given is equal to 4 cm, which is the half of PO. That means the median in this triangle is equal to the half of the hypotenuse. That means it's a right angle triangle. So we can say that in the triangle OKP, AK is equal to 4, since P is the symmetric of O with respect to A, so A is the midpoint of PO. So OP is equal to 2 times OA, which is 2 times 4, which is 8. So AK is equal to really the half of OP. And that means AK is a median segment related to OP in the triangle OKP, and AK is equal to the half of OP. So the triangle POK is right-angled at K. Now B, show that PK is tangent to the circle C. We have to prove that PK is tangent to the circle C. What does it mean tangent? That means that passes through the circle with only one point and perpendicular to the radius of this circle. So a straight line PK is tangent to the circle if it's perpendicular to the radius OK at K, at only one point, which is K. Since the triangle POK is right-angled triangle at K, that means PKO, the angle at K, is equal to 90 degrees. But OK is a radius, also is a radius of the circle OK, and that means PK is really tangent to the circle C. C, calculate PK. So easily using the Pythagoras relation in right triangle OPK, we can say that OP, which is the hypotenuse of this triangle, is equal to OP squared is equal to OK squared plus PK squared. So always the Pythagoras relation says that the hypotenuse squared is equal to the summation or the addition of the two other sides squared. But we don't want to calculate OP. We want to calculate PK. So we can say that PK is equal to OP squared minus OK squared. That means it's equal to 64 minus 16, which is 48. But PK squared is equal to 48. PK alone is equal to the square root of 48, which is 4 times square root of 3. This is the figure again. We have question number 3. The tangent to the circle C at B cuts PK at M. We have another tangent at B. Perpendicular to OB, of course, because it's a tangent, must be perpendicular to the radius that cuts the circle at B. This tangent cuts PK if we elongate PK, of course. If we elongate PK, it meets with the tangent, the new tangent, with point M. This is how we draw it. So A, show that the triangle MKB is isosceles at M. That means we have to prove that MK is equal to MB. Since MB and MK are two tangents drawn from M to the circle, so MB is equal to MK, of course. So the triangle MKB is isosceles at M, because MK is equal to MB. Why MK is equal to MB? Because MK and MB are two tangents to the same circle. B, show that AK is parallel to OM. Since MB and MK are bisector of BK, but AKB is equal to 90 degrees angle inscribed in a semicircle. So AK is perpendicular to KB. So KB is a common perpendicular to AK and OM. And that means AK is parallel to OM. Deduce that K is the midpoint of PM and OM is equal to 2 times AK. In the triangle OPM, we have A is the midpoint of OP, then AK is parallel to OM, so K is the midpoint of PM, and that means AK is equal to the half of OM, that means OM is equal to 2 times AK. Conserve of midpoint theorem. For show that the 4 points K, O, B, and M belong to a same circle whose diameter to be determined and radius to be calculated. The triangles OBM and OKM are right angle, have a common hypotenuse OM. So the 4 points K, O, B, and M belong to the same circle of diameter OM, and radius R is equal to the half of OM, K which is equal to AK, which is 4 centimeter. Proved before. This is proved before.